Hello, this is Dr. Hassan with Innovate, and this is lecture number 1, Electrical Safety for Chapter 1, Circuits Basics for the course Electric Circuits 1. This is an undergraduate course, and it consists of electrical elements, electrical sources, electrical methods, and theorems to analyze any electric circuits. And we will cover all this course lecture after lecture, but we decided to start with lecture number 1 on electrical safety for the importance of safety when we deal with electric or electronic circuits in the lab, in our workshop, or in any establishment. This is a disclaimer for you to read. I cite 3 references on in electric circuits, a book by Nelson and Irwin, and my class notes. The course contents, we will start with Chapter 1 today with Circuits Basics. Then we'll talk about resistive circuits in Chapter 2. Chapter 3, we'll talk about nodal and loop analysis. Then in Chapter 4, we will talk about Thevenin's and Norton's theorem. Chapter 5, we will cover capacitance and inductance. Chapter 6, we will talk about first-order transient circuits. And Chapter 7, we'll talk about second-order transient circuits. The contents for Chapter 1 are, today we'll start with electrical safety. Then we'll talk about system of units. What is circuit analysis? Voltage and current, circuit elements, power and energy. Electrical safety. Safety is everyone's responsibility, especially when using electricity. None of us can fully depend on others to provide a safe working environment. This is why we say it is a personal responsibility. You have more control than anyone else over your activities and the caution you use when participating in those activities. Unfortunately, most of the accidents take place because of ignorance, because we don't know how complex and how dangerous electrical current and electrical voltage are. Also, most of us, we assume things, and our assumption is often wrong. We assume things are safe, but indeed they are not safe. And we'll talk about those really in depth. This lecture is considered one of the most important lectures in electrical circuit analysis and in electrical engineering as a whole. And this encompasses computer engineering, electronic engineering, and any field, power engineering, and any field where we use really power source and current sources where the danger may exist. General precautions for electrical safety. Never work alone. Learn first aid, especially CPR or cardiopulmonary resuscitation for electrical accident victims. Learning CPR is extremely useful in any case, but especially when you work in an electrical environment. Turn off power before working on electric and electronic circuits, except when absolutely necessary. Consider all wire and terminals to be live until proven otherwise by a safe test method. So you assume the wire really is fully insulated, but often this assumption is wrong. See, I told you really we make a lot of assumptions, and these assumptions may cause us severe and dangerous accidents. Be sure your test equipment is operating properly before you use it. Do not work on circuits or equipment while standing on a wet floor or when touching plumbing or metal objects that may provide hazardous earth-ground path. Wet floor is really very bad. It will reduce your resistance and will be a dangerous path for current and electric shock. Whenever possible, make current and voltage measurement with one hand in your pocket or behind you. This will reduce the flow of current to your body. Resist the temptation to throw a switch to see what happens. Turn off power and unplug equipment before checking or replacing fuses. Locate and correct the cause of a blown fuse or a tripped circuit breaker before replacing the fuse or resetting the breaker. Ask why this happened, and try to solve the problem. Replace defective cords and plugs. Form a habit of inspecting for defects such as frayed wires, loose connections, and cracked insulation. Very dangerous. Do not assume your wires are safe. Do not assume your cords are safe. You have to inspect them and test them. Remove metal jewelry, watches, rings, chains, necklace, etc. Necklace is so dangerous. Before working on circuits and equipment, always check the electrical ratings of equipment you use and be sure you use that equipment within its ratings. In general, treat all circuits as if high voltage or high current or current is present. So those are really a list of general precautions that you need really to remember them. They are extremely important. Ground wire. A primary safety measure is grounding equipment chassis through a wire in the power cord. This practice is referred to as green wire ground or field wire ground. Now the green wire ground and the field wire ground will have no value if you don't have a grounding wiring system in the establishment, which meets really the National Electric Code or the NEC, because the whole system has to be really connected to a grounding rod, which you dig wide deep according to the NEC, and you place it in and connect it to your household or to the establishment, and the third wire in the cord or in the plugs connected to this ground wiring system. The main reason for a ground wire is to provide a path for any fault current. In the process, the current might rip a circuit breaker or blow a fuse, which would alert the user that the instrument had a problem. Before working on circuits or equipment, be sure that the establishment, laboratory, workstation has a grounding system that meets the National Electric Code, NEC, just we talked about. Believe it or not, a large number of people lose their life every year due to ungrounded equipment. And one of the most dangerous equipment used in households is the iron, and especially those wet iron or steam irons. Okay? To iron our shirts or clothes with, or they are really very dangerous. So the ground wire, the green wire ground, must be connected, or the field wire ground must be connected. Floating measurements. Floating measurements are reference to some voltage or other than the ground potential. One technique of making floating measurements is to use a buffer to isolate the device being tested from the measuring part of the test equipment. And there is many buffers produced by many companies available in the market. Another way of making floating measurements is to isolate the power supply of the test instrument from the AC power line ground reference. And again, there is many isolators that you can buy to do that. What is electric shock? Electric shock is a sudden violent impression caused by the passage of electric current through any part of the human body. The human body is electrically controlled. That is, it operates in response to own minute electrical signals. Everything in the brain has electric signals. All the nervous system is based on electric signals. Different persons have different resistances and sensitivities to electricity. Electric shock depends on the source voltage and the individual person's resistance. Both will determine the amount of current flows in the body. We will talk about Ohm's law and simply how the current is calculated based on the voltage and the resistance. The higher the voltage, the more the current. The higher the resistance, the less the current. Human resistance varies between 500 ohm, or if your skin is wet, to 1.5 kilo ohm, 1,500 ohms. The threshold of current perception is about 0.5 milliampere for 99.9% of the population. Well, this means that 0.5 milliampere is a threshold for 99.9% of the people. So for 1,000 people, 99 or 999 people may have this threshold. And this is milliampere DC, not AC. We'll see the AC, how dangerous, in 1 second. Now, the let-go current is the maximum current a person may tolerate and still release the Graf's conductor, which caused the problem, by using the muscles directly stimulated by the current. We call it the let-go current. The let-go DC current is 9 milliampere for men and 6 milliampere for women, with a DC voltage must not exceed 30 volts. Let go, it means ability to let the conductor go after we grasp the conductor, and the conductor causes us the stimulation for our muscles because of the flow of current. The current caused by ordinarily household voltage, which is 120 volt in the United States or 240 in other places on Earth, showing that a lethal shock and death can occur based on the resistance of the human body. If touch any line with 120 volt or 240 volt, okay, this is almost an imminent death or a lot of damages. AC current of 20 micro, not milli, 20 microamperes can produce fibrillation if injected directly into the human heart. 20 microamperes. This 20 times 10 to the power minus 6. Very small amount of current can cause really damage to the heart and can kill. High currents can affect the nerve centers, causing paralysis and respiratory failure, hemorrhages, and burns. Delayed death may result from serious burns or other complications. So if you touch a current source or a voltage source, and this current source, voltage source, will cause you enough current to flow through your body, this may cause a huge harm paralysis, respiratory failure, hemorrhages, burns, and death, or maybe a delayed death. It means if the one does not die at the second of touching or grasping the conductor, he may die later because of the complications from burns and related damages. Now, this is the assumption that always people make. We have circuit breakers to protect us. We have fuses to protect us. Wrong. Can we depend on fuses and on circuit breakers? No, 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 and absolutely no. Fuses and circuit breaker will open the circuit under fault condition. But the time it takes these protective devices to open is long compared to body reaction times an electric times reaction which cause the electric shock and death can result. So the time actually for the body reaction is much faster than the time needed to generate a fault or to trip the circuit breaker or to break the fuse or open circuit fuse. And the time really that the current will flow to your body is faster, and this may cause huge damage and even death. So you cannot rely on fuses and circuit breakers at all. However, there's something called the ground fault current indicators, or GFCI, are devices that sense current in hot and neutral AC power lines. If the currents are unequal, the difference must be a ground current, which causes the GFCI to open the circuit. Now, the GFCI can be used to prevent severe electric shock when the line current is diverted into a fault. So the line current will be diverted to a fault. However, you may get a shock, okay? But it may not be that severe if the GFCI works properly. Now you may see a symbol like danger, electrical hazards. You need to keep out and stay very careful. Or danger, high voltage, or your palm with a line on it. This is keep away, especially with high voltage establishment, because they may cause you a huge damage and even death. So in conclusion, electric currents may produce deep burns, and currents sufficient to raise body temperature substantially will produce immediate death. Okay? You know what temperature does to the human body. Delayed death may result from serious burns or other complications. But if the death is not immediate, it could be delayed. Now, we did not talk about the electric components in electric circuits, like capacitor and inductor. Those are very dangerous, both of them, capacitor and inductor, because they may charge, okay, likely to be very hazardous. Their discharge is likely very hazardous. Now, the interesting thing, if you have a capacitor and inductor in one circuit and you reach the resonance, could be quite dangerous because the voltage across the capacitor and inductor could be extremely high at resonance or close to resonance. So in conclusion, be very careful. Be very careful. And we decided to start actually this course with this lecture number 1 for electrical safety, for the great importance of being safe. Being safe and knowledge actually is the key. So don't assume anything. Don't assume a safe wire unless it is safe, a safe cord unless it is safe. Don't depend on a circuit breaker or a fuse at all. and stay away from electric circuits if there is no supervisor, especially if you are a student. You need a supervisor all the time to supervise you. I need somebody who knows CPR close to you as well. This will conclude lecture number 1. I thank you so much for listening. Please subscribe on clicking on the blue circle. We just started with this course, which is Circuits, Electric Circuits 1, which is undergraduate course. Sincerely, Dr. Hassan. Thank you so much.